Okay, now here's the big overview of strings. Okay, so I'll write quite a bit here at the beginning. Strings are much like lists, where each item is a particular character. Okay, now, but in that same way, they're different. Different than lists. In that each item must be a character. Okay, so that is the string 12, for instance, is the character 1 followed by the character 2. Not the numbers 1, 2, nor the number 12. That's a 12. Okay, so it's definitely these characters that are all put together here. Okay, so but strings are important, right? Because most data we have out there exists as strings. Right? We have names, addresses, we have items that are ordered, all those different things. That's all strings. I didn't mean for that to be a period, I guess. Strings in various types of documents. So typically, we have to get at the strings first and then mess with the strings to actually get, say, numbers or values, words that we want. So it seems reasonable that we would like to be able to do lots of stuff with strings. Python has 70 built-in methods, tools to work with strings. Okay, we'll look at a few. Okay, we won't look at all 70. All righty, so well, let's start taking a look at some of those. And we'll go over them here, and then I'll do separate videos on most of the stuff as well, where we look at the Jupyter Notebook and mess with it there. So one thing we may want to do, we may want to get any given character item of the string. Okay. So for instance, you know, maybe we have address equals 210 Lindsay Wilson Street. Okay, so we have that as our street address. And you may just want the numbers or something like that. Well, strings are indexed. And so, now this is a pretty long one, so I'll try to write all these out. So here, index, and so we always start at 0, just like in lists. It starts at 0, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I'll have to continue on another line here. 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and I think it goes up to 24. So here would be our 2, 10. We'd have a space here. Lindsay. Another space. Wilson. And street. Okay, so now you could also have negative indexes. We won't really use them much, but you should be aware that in Python people do. It's just they're not real common in languages. So the negative index would go -1, -2, -3, -4, -5, and so forth, all the way back in this case until what, -25. So going positive numbers, we start at 0, but the negatives actually start at -1 at the very end. So it's kind of strange that way. But so, as we look at this, if we were to just use that index and say, well, I want address of 0, I would get 2 because that would be the 0. Similarly, if I used address 4, that would turn back, oh, sorry, not 4, 3. Um, 210, and then the blank and Lindsay Wilson Street. So it's going to turn back a blank, which would be a space between two quotes. And if we ask for address 24, address of 24, we would get back T. Actually, those should be in quotes. Okay, so that's how the indexing works, and we can always ask for those. So we could say print address of 0, print address of 24, things like that. Okay, well, along those lines, we just may need to know the length. Oops. The length of a string. And so, for instance, in this case, we said length, just len, of address. We would get the number 25, because from 0 to 24, there are 25 characters. And so you see it'll give a number that's just slightly bigger, one unit bigger than the last index, okay, because of the 0 tossed in there. So that's a couple things. 3, well, we may want to concatenate multiple strings. Now, the way I do this actually wouldn't be the best in the sense that I wouldn't get the kind of formatting I want, but we'll worry about formatting later. So, for instance, we could have a name, equal something like Lindsay Wilson College. We have the address already, a street address. We might have city equal Columbia. State, so you might be getting this out of some database or something like that, is Kentucky. And zip is, say, 42718. And then what we might want to do is have something like mail to equals, and then to concatenate, we just use a plus sign. So name plus address plus city plus state plus zip. And like I say, that wouldn't be real pretty because it would do name Lindsey Wilson College and then put no spaces and start the address and so forth. And there's no comma between the Columbia and the Kentucky and so forth. So it wouldn't really be very pretty, but this is the idea. So we could concatenate that way. Okay, so along those lines of using indexes and so forth, we may wish to may want to traverse. Okay, so this is same thing as saying loop through the characters. Okay, so when we talk about a string traversal, we're just looping through each of the characters. And so our couple of different ways you might do that. You might say, for C for character, I guess, in address. And then you do a bunch of stuff here for each character, I suppose. You might check to see if it's equal to a particular value or something like that, or you may want to do it with the indexes for whatever reason. It could be you're just trying to go until you get to some spot, which tends to be a while loop. So you might do something like, I equals 0, and then while I is less than the length of address. Didn't give myself quite enough room there. A colon. So while that's the case, then you may want to do some sort of stuff. And I did the whole length, but it could be that you do less than the length or something like that. But and then after that, you would update the I equals I plus 1, and keep going through. So either of these will traverse the whole set of characters in address. And it just kind of depends on what you want to use, what you're doing and so forth. But you can do a for loop that way. You could even do the for loop where you, instead of in address, you could do a range of the length of address. It should be fine. Okay, what's something else we want to do? We probably want to take slices. Okay, substrings. Of strings. Okay, and we just use the indexing. And we give it a start and typically a finish, but it doesn't include that last number. So if you want to finish on a particular index, really you need to kind of think of it as that finish index and then plus 1. You know, so for instance, you might have something like for address, right? You might have address of I don't know, like what was got to go back up here to find my indexing. So address of like 4 to 10 would give me the word Lindsay. So address of 4, but you see I'd need to use 11. And that will give me Lindsay. Okay, so I had to go one more. Now, the way the book says you could think of this is they use the word bananas. So, you know, suppose I have a string that's equal to bananas. They suggest that you look at the indexing as so let's write this out with plenty of space. They would say, oh, think of this as 0, 1, 2, 3, 4, 5, 6, and 7. And so when you do this indexing, you're going from, you know, say 0 or 1 or whatever. But, you know, so for instance, if I wanted the AN, you see under thinking of the indexing this way, I would want to go from 1 to 5. And then it sort of makes perfect sense at that point, you know, whereas if we had done the 0, 1, 2, 3, 4, 5, 6, then, you know, you would tend to want to think of going from 1 to 4. But if you use their sort of conceptual scheme here, you see you would go from 1 to 5 because it would give you everything between indexes 1 and 5. So that's a way to think about it. Now we can just give a start. Oops, or strat, start. So in this case, you know, we could say something like address and now let's go back up here. Maybe we should use bananas, but let's go to 19. So let's say, you know, if we said address of 19 like that, that would just be the start. Put colon in there. Address 19 colon and then just don't put anything. That's going to give us street. Okay, because that began at index 19 and went to the end. You know, on the other hand, we could do give the end, just give end or finish plus 1. So if I did something like address and well, no, don't need the 0, but so colon 3, that would give me, the indexes of 0, 1, 2, which was 210. Okay, so you can use that to shorten things up a little bit. And it could be that, for whatever reason, you don't need to know the full length of the string, so you don't compute that. And that so you may not know the end, and that's why you might use this up here. You just know where you want to start looking, and go from there. Now, Python can use negative indexes, like we said. Okay, negative indices. But again, it usually wouldn't necessarily be worth it. But, you could say, well, what are often you're told, like, you're asked for the last 4 digits of a social security number or something like that, right? So, you could, again, do something like address, and if we want the last 4 digits, we would say -4, and we could, and just do it like this, and that would give last 4 characters. So it is useful, but a lot of languages do not have the negative indices. So, it doesn't move well between different languages, but it is possible. Okay, so that's slices. 6, certainly we could compare 2 strings. All right, now what it does is it uses alphabetical order. Now, when you start talking special characters, digits, that kind of thing, you would have to look at the order of those. You might have to just experiment with them, something like that. But it uses alphabetical order. Now, except you have to be a little careful. Uppercase comes before lowercase, and it knows the different cases. So in this case, if you ask the question, is zebra with an uppercase Z less than anteater, this would give you true. Okay, because the uppercase Z comes before the lowercase a. All right, so that's the idea of comparing strings. Now the text, toss it in here. This isn't really some sort of tool you're using with strings, but we'll put it in here about the same relative position as in the text. Strings are immutable. Okay, so in other words, you can't change pieces of them. So for instance, if you just said, S is equal to string, like that, you couldn't change it to string by saying something like S of, what is it, 0, 1, 2, 3. So S of 3 equals A will give an error. Okay, so you can't do that. However, now to don't get the idea they can't be changed in other ways. So for instance, you can reassign. Reassign. Try that again. Reassign S. So for instance, you could say something like S now equals strings. Okay, that would be fine if I called it string up here and then but wanted to change it to something else. Yes, I can change the whole thing by reassigning S and by concatenation. So, for instance, I could do something like S equals S plus the letter S at the end. And, this would, well, if I started with this S up here, this would give me strings. So that is legal to do. So I can concatenate, I can place something on the end, or I could place something at the beginning by shifting the order here, right? I could have done the S, the letter S plus the string S, in which case I would have gotten SS, or S string, something like that. But that's fine. You can do that. So to say you just can't change them, period, is not really correct. But you can't change pieces of them trying to use that indexing notation there. Okay, so I could change S to be strings from string either of these ways. Now you may just want to check is a substring in or not in a string. So, and I do that just with those particular operators. So if I go ahead and I let S equal strings, then if I ask, T in S, that would return true. If I ask if K not in S, oops, K not in S, that would also return true. However, if I said H in S, that would return false. So you could use these in if statements or loops or something like that. And, similarly, if I said I not in S, that would also return false because I is in there. Okay, so that's ways to just determine if particular letters or characters. So, we could have also done, str in S. That would imply true. But of course, this is a substring. So if I said S R, what I got there? Maybe I, SRI, in S. Well, that should give me a false because that substring is not there. There is no SRI. There's an STR or STRI or TRI, but not an SRI. So that should return false. So I can check for substrings as well. Okay, 9. So quite a few things we might want to do. How about find the index of a character or substring. And so if I did the bananas thing, S equals bananas. Then if I said S dot find, and I wanted it to find A, what it'll do is it'll find the first occurrence. So this will give me back the index of 1. Okay, because that first A is at 1. Now sometimes you want more than that. Well, you could do some sort of loop where you find the first one, and then if we said since that's a 1, if I said S dot find A, but then I put a 2, it's going to give me a 3. Because again, this is 0, 1, 2, 3, 4, 5, 6. Okay, so if I did that, it says don't start looking until index 2, and I would find 3. But of course, there's yet another one, and so I could do an S find A of 4, where I just took the 3 plus 1. That would end up giving me a 5. So it just goes to the end. Now, I could also, specifically put the end in there. And actually, it doesn't matter. So if I said A, and then 4, and then 6, that will give me the same thing as S dot find A, 4, and 7, because that's the length is 7, but the last index is 6. It doesn't care. It'll do either of those. But that'll also give me, if I said S dot find A, and I said, like -2 or -3. So if, said -2, those will all end up giving me the 5. Okay, so you could use that negative indexing, but again, it's really only in Python that you can use it, but it can be very powerful. Okay. We're getting to about the end here, so we may want to split a string. Now what it does, it splits the string at the white spaces. Now these could actually be spaces. They could be tabs. They could be things like line feeds and returns and stuff like that. Things that, kind of format a string. Could be any of those. So if we go back to address back there, where it was 210 Lindsay Wilson Street, if we said address.split, what we would get is a list actually of strings. So it would return 210 Lindsay Wilson Street. So, of course, this could be useful if I need to get like first name, last name out of a whole name, that kind of thing. So, split could be very useful for doing something like that. But again, this is a list of strings. And then finally 11, we might want to format a string. I'm not going to go into all of that here. It's kind of a bigger thing to look at. We'll have a video specifically on formatting a string. So there you go. There's a lot to that. But that's what we're doing and why we might want to do some of these things. Okay, so there we go.